Yeah, hi everyone. Welcome to Next Gen AI with Sai YouTube channel. So today I'm doing something different, something something uh, without preparation. Although I have few knowledge about it, but I think let's do it. Okay. So generally, what happens? I do some kind of preparation before I do the recording, and I think same goes with everyone. But now I'm taking the topic without a very thorough preparations. So we will do it on the fly. If I'm stuck somewhere, I'll take a help of Google or AI and get that clarity. If you guys are aware, don't stop yourself uh, with don't stop yourself you know for not doing any comment. So please, if I'm doing any mistake while explaining, please feel free to drop your comments in the comment section of this video. Let's see how you guys feel with this approach, and if you guys feel this is a great, okay, then I'll keep doing such a things. Okay, although I'm not doing live, but yeah, I can plan something doing live. If I get good response, then we can do it live, so that people also start adding their thoughts while doing such a things. So recently, Google has dropped a paper, a kind of a 70-page white paper on context engineering, and these are the authors who did this nice job. Thanks to Kimberly Milan and Antonio Goulet. Uh, Please forgive me if I'm not pronouncing your name correctly. These are some content contributor to this paper along with the main author, curator, and designer. Thank you, everyone. So what we are going to read in this paper, um, introduction, definitely, the context engineering, what is context engineering. Then we will talk about session, right? uh, yes, session. Then something variance across framework and model, session for multi-agent system. So I assume that how we will work on the session part when we are working on some multi-agent system, right? Then interoperability across multiple agent framework, production consideration for session, managing the long context conversation, that is trade-off and optimization, correct? Then once we done with the session, we will start looking on the memory part. So specifically, we are going to look on the types of memory, then types of information, organization patterns, right? Storage architecture, creation mechanism, and memory scope, correct? So these are the things we are going to learn about memories. Don't worry, we will try to understand what is the difference between, and let me remove this highlighted part. Yeah. Then we will try to look into the difference between session and memory. We are currently unaware about that. Okay. So let's take this as a challenge. Fine. And then once we done with this, then we will think the memory stuff still continue. And I think whole it's about memory, right? For example, how we can use memory as a tool. Then we are going to deep dive into the memory extractions, memory consolidations, then memory, oh, whatever. Okay, okay. And then let me, yes. Then we are going to deep dive into memory extractions, memory generation. Uh, then we are going to learn about the memory provenance, right? Accounting for memory lineage, then triggering how we can use memory as a tool, background versus backlog operations, right? Uh, then memory retrieval, inference with memories, memories in the system instructions, memories in the conversation history, and then procedural memory. Correct? So yeah, so I think okay, still the table of content is there. Then we are going to use testing and evaluation, and then what are the things we are going to consider in production considerations, memory, right? And then privacy and the security risk. Now, if you look at this paper, it is broadly classified into these sections. Uh, I mean, the first section is context engineering, definitely. Then second is the session, and third is the memory. When we are looking into the session, then this is something that what production consideration we will look into it. So I think this is something not major but important if someone trying to build the AI agent, right? So we will look into it. And then if you go down here, we will also look into something. I've seen somewhere, yeah, in production consideration for memory, right? And then definitely the conclusion. Probably I'm not going to cover in single video because I do not want to make this video as fast, you know, or quickly to finish and give summarization. I think you can use very native AI tool, Notebook LM or someone where you can upload and get the summary. But that is not the intention. Intention is to go deep dive, study along with me, okay, and make benefit from this to our knowledge, right? So let's start with the first page. I mean the introduction. The stateful and personal AI begins with context engineering. Okay, great. Um, so as you can see, recently everyone is talking about context engineering. I remember before context engineering, prompt engineering was making a noise, but eventually we understood that prompt is not everything. Context is something very important, and Andres Karpathy made very nice statement that consider context as a RAM. If you do the analogy with our computer, then context is a something, a RAM. RAM, when you talk about the RAM, is nothing but the what is readily or immediately available to computer to think. So the things which is immediately available, accessible, we use to store into the RAM, and those who are not quickly or require not frequent access, we usually store in hard drive. But let's not go into that. But yeah, so what is context engineering? It's a something stateful and personal. AI begins with context, and this is the statement they have made. Now let's try to read the introductions. Okay, so these are the highlight I have made just for starting the recording. But yeah, we look into it again. So what this did, they said this white paper explore the critical role of session and memory in building stateful intelligent LLM agents to empower developer to create more powerful, personalized, and persistent AI experience. Okay, to enable large language model to remember, learn, and personalize interaction, developer must dynamically assemble and manage information with their context window, and this process is known as context engineering. Now, if you look at the definition of context engineering, it is they're trying to say that whatever informations, if you want very personalized interaction with the LLM, then it is very important to provide the information to the LLM, okay, which is, I say, dynamically assembled, it's not static, okay, within their context window. So I hope everyone aware what is context window. Context window is nothing but the capability of model to handle the input, okay, at once, right, with, with one call, right, with one API call. So I don't remember exactly what context window of each every model, but yeah, generally on an average I remember 30k. Even there are few model supports context window more than 30k thousands, right? 30k, sorry. So so when you hit the API call, right, on an average, I'm saying it go beyond that. I know that Gemini models has largest context window as compared to other LLM model, but let's take one consideration that, so whatever informations you are sending at one API call, it should have some length, right? It should have some window to digest, and that window is called as context window. Now, every time when we are sending this information, this information must be dynamically assembled, means doesn't require that every time you are sending the fix, right? So this process, so whenever you are asking, it is very important that LLM must remember that who is asking the question, what is the persona, okay? Because LLM never remember your history, okay? Because LLMs are stateless, right? They are not stateful. So each and every call to LLM, so let's say this is a LLM, right? Okay, this is LLM. So every time the call, the question you ask to LLM, it's always new, right? So this is called as a stateless. But when we are doing interactions with LLM through agent or through chatbot, it is quite difficult to provide the informations, same information to LLM again and again. So it is our job how we can how we can keep this information always available so that LLM will not lose the context even if we are asking a new information. So the process of doing this is called the context engineering. So this is what I understood. So these are the core concepts as I mentioned earlier. This paper is going to cover. So first is the context engineering, second is the session, and third is the memory, right? Okay, so before going into each, let's try to understand the definitions they have provided. The first, they are saying the process of dynamically assembling and managing information within LLM, right? So dynamically assembling, I mean, we have to provide these informations dynamically, not a static every time same. It will change, right? And managing informations, okay, so we have to manage those informations. Though we are asking new questions or new informations, we have to manage that informations, right, within the LLM context window, so that we enabling the stateful and intelligent agent. This is nothing but the context engine. I hope we understood this definition, right? Let's go to the next topic, that is the session. Now what is session, right? The session is nothing but the container of an entire conversation with an agent, right? Which hold the chronological history of the dialogue and agent's working memory. So while I'm reading this, I feel that, let's say you are doing conversation to the agent. So whatever conversations you are doing to the agent, it should remember the previous history of your conversations, right? So there might be a multiple sessions. So for example, you can Imagine, just for a simplicity, you're opening the new chat every time, right? So maybe the first chat is related, you are asking something related to the program you are doing, or maybe coding related questions. Some second question you may be asking related to the your financial stuff. Third questions maybe you are asking for research stuff, right? So each each conversation we can consider as a session. So here we are opening three sessions. So we want each and every sessions that we are starting, it's a something, a new topic, right? And it's okay that we revisit every chat. So for me, what is the session is something which holds our history of conversation or history of dialogue, right? And even we can consider this is the agent's working memory. So whatever actions you are sending to the agents, so for that particular time period, whatever dialogue you are making with the agent, that particular time period, we consider this as a session. Now let's go to the third topic, that is the memory. So what is memory? Memory, as mentioned, it's a mechanism of long-term persistence, capturing and consolidating key information across multiple sessions to provide continuous and personalized experience for LLM agent. So this is, again, let's take a chat GPT. Here you have a new session, one, two, three, or you can say a chat session. But still we are chatting this session. You no need to always provide your basic information which hold across this session. For example, a person A who has this account is not always giving information about him while asking question. Those personalized informations are stored in a long-term memory, or maybe you can say a database, right? Which is a long-term. So this is called as a memory. This memory serve as a common access to all your session, so that your personalized experience is maintained by that agents. So ChatGPT, you can consider this as a agent. So this is called as a memory, and these are the topic that's something we are going to learn in detail in this paper. This is what I understood. I hope meanwhile you feel this is a useful, that the way we are trying to go through this paper. Okay, fine. So let's start with the context engineering. I think this is a small topic as compared to the other while we were going through the index. So let's try to cover this context engineering part before we go into the session. Okay, so so session will start here by on the page number 12. But let's see how we can cover as much as possible. I do not want to make this video lengthy, but yeah, let's at least try to finish the context engineering part here. So LLMs are inherently stateless. I think everyone agree. These are the stateless. I mean, they don't maintain the data or the history, the informations that we are talking to the LLM. So this is called as the stateless. It doesn't carry any information for next iterative call. Outside of their training data, their reasoning and awareness are conformed to the information provided within context window of single API call. So this presents a fundamental problem, as AI agent must be equipped with operating instructions, identifying what actions can be taken, the evidential and factual data to reason over, and the immediate conversational information that defines current task. I think yes, we agree that whatever informations we are giving, okay, within their context window, Okay, it's all go within that API call. Okay, but what is the problem with this? The problem that we always, you know, try to give the informations so that, you know, the reasoning is not happening properly, right? So as a LLM is stateless, so it may happen that LLM lose the context, right? So we want to make this LLM as a stateful, intelligent agent which can remember, learn, and personalize interactions. Developer must construct this context for every turn of conversation. So this dynamic assembly and management of information of LLM is known as context engineering, right? So what is context engineering? It's not, now I hope you are able to understand the difference between the prompt engineering and the context engineering. So when we are asking a prompt is a way, the best way to ask a question to LLM to get the good output. But context engineering is not about it. Context engineering is about how we can make the LLM so that it will remember and learn about the user behavior, about their past experience, right? So that we no need to give the same information again and again, and it will be the useful conversation. So this is the something they are talking about, the context engineering. Now context engineering represents an evolution from traditional prompt engineering. Definitely we everyone agree. So after the prompt engineering, the context engineering is very popular. It is not something like that. Earlier we were not aware about this methodology. Even before this term context engineering came, the application that wasn't built on AI, okay, they were also giving those kind of information through prompt. But you can say it's a advanced and the mature way of using the prompt, right? So prompt engineering, as we mentioned earlier, it is totally focused on crafting optimal, often static system instructions, right? the the focus is not the personalization. The focus was getting the good output. However, context engineering addresses the entire payload, dynamically constructing a state-aware prompt based on user conversation history and external data. So I can say that with this line, with this line, that prompt is a static way, right? You have your questions or maybe different type of prompt and get the output. But the context engineering is a dynamic prompting. So this dynamic prompting, I mean, the prompt will be created based on the conversation history that earlier made, based on the user and based on the external data. This is what the context engineering. So what it involves strategically. Now when we are saying dynamically, means there is something happen dynamically, right? So what it involves selecting, summarizing, and injecting the different type of informations, right? It doesn't mean that we are sending everything. We have to select, right? We have to, so when I say summarizing, means we have to summarize the conversation that we have made earlier. Okay, injecting the relevant information. So if I'm asking something, then it is very important to provide some information about that, right? So that we are increasing the relevancy score and minimizing the noise. So if I'm asking about, let's say, topic 1, I should get my output with related to the topic 1 rather than something else. So this is called as a relevance. So we are trying to increase the relevancy score here. So when we say external data, so how one can provide external data? That can be provided with something called as a RAG, that is retrieval augmented generation, then something called as a session store or memory managers. which manages the external information. This agent framework must orchestrate this system to retrieve and assemble the context into final prompt. So whatever final prompt we are sending to LLM, it must be comprises of all these things. That is the external data, conversation history, and the information about the user. So your final prompt is not only the instructions. Please remember, when we are talking about the context, it is not about the instructions, what you want, but along with what you want, you also have to provide the data which supports what you want, the information about the questions that you have made earlier, and the right informations through this memory RAG and all. I hope now we are clear the difference between the context engineering and the prompting. Let's move to next. So here they have helped us to simplify our thought process. So think about context engineering as the mice in place for agent, where so now they are giving some analogy here. For example, okay, so let's consider that where chef gathers and prepare all their ingredients before cooking. Now, if you only give chef the recipe, okay, I mean the prompt, okay, so they might produce okay meal with whatever random ingredients they have. So you said that this is the recipe to make a dish, right? So it is has a possibility they can make as per their understanding. But however, if you first ensure that they have all the right high quality ingredients, specialize, you know, the specialized tools, clear understanding and present, they can reliably produce the excellent and customized results. And the goal of content is to ensure that model has no more and no less than most relevant information to complete the task. So in a short, this is very nice example in the paper they have mentioned that if you if you want to understand the context engineering, it means it is not only about the what you want, but how you want with the supporting information. Like in the chef, if you are just providing the recipe, you may get the output, but that may not up to the mark. So to improve your output, you have to give a clear guidance that in what proportion you want the ingredients, which ingredients that you use. There might be a different type of ingredients you have while preparing, but which quality ingredients you want, what is the duration to cook the meal, and many more stuffs, right? So when you give such a informations, then this is called as the context engineering. I think this is a very nice analogy the paper has given, and this has also helped me to clear understanding difference between the prompt engineering and the context engineering. Now, the context engineering governs the assembly of complex payload that can include a variety of components. So context to guide defines the agent fundamental reasoning pattern and available action dictating as a behavior. Okay, let's go below. So system instruction. Okay, so this is, I think this is the first important thing that we need to remember. System. So what is system instruction? High level directives define the agent's persona, capabilities, and constraints, right? So let's say you are building one agent. So when you are building agent, let's take a, maybe you can say a cooking agent that we have just seen. So what is that agents? We have to give the persona to that agent. What is his capability? Uh, For example, cooking agent capability is to do the cooking as per the available ingredients, nicer dish for specific things, and what has the constraint, what has to do and what things are not to do. So these are the constraints are followed. So when we are doing the context engineering, so the first important that we have to give the system instructions. Second, tool definitions. So definitely while doing something, they may require some tools, right? For example, let's take another example for coding agent, right? So once you made the code, right, the coding agent does the code, they have to push that code to GitHub, right? So to push the code to the GitHub, they require access to the GitHub API. So this is will be the act as a tool. So we have to give the schema and API function that agent can use to interact with the outside world. For example, if the coding agent wants to analyze some external code, so we have to provide some API search, web search capability, right? So this is again fall under the context engineering. So we have provided the system instructions, then we have provided the tool definition, so that the agent is aware about this tool. And the third is the few short example. That means we have to give some example that how one agent can use that tools, or how agent can use when some question will come, so that we are giving some couple of examples in the context, so that agent will do their work based on the example that we have. So we have to provide some context, which is something guide reasoning, so it will enable agents to reason about the questions or the instructions they receive. The next part is evidential and factual data. So this is the second part of your context engineering. So is the substantive data that agent reason over, including pre-existing knowledge and dynamically retrieve information for specific tasks. It serves as the evidence for agents. So one thing which come long-term memory, that is persistent knowledge about the user topic and gather across the multiple sessions. So whatever topic user is asking, let's say about the code, so each and every industry has their norms or guidelines while doing the coding. So those guidelines has to be stored in a persistent storage. And then when I say persistent storage, it means a database I am talking about. Even across the multiple session, whatever informations we have gathered, that has to be stored in those multiple long storage. Second is the external knowledge, right? So when we are trying to retrieve those information from your storage or the database or maybe document, then has to go ahead with the RAG, that is retrieval augmented generation. The third, when we're talking about the data, then third is the output. So whatever output your tool has given, that also we need to store somewhere. For example, if the once you use the tool, it may possibility that the tool gives the success or the failure, both the output we have to store, because that output will help us your LLM model to do further stuff. Then sub agent, so agent can be comprises of multiple, so the conclusion or the results written by the specialized agent have been delegated a specific substance. So as we can say, there is a main agent, and within a main agent there are multiple sub agents have. For example, within a developer agent or development team, there might be a product owner agent, coding agent, quality agents. Then there may be a evaluate security agent. So each consider as a sub agent. So we have to store this output so that the main agent is able to take the output, right? So these are the some information is very much important. Then artifacts. So there are few informations which may be related to no textual data, like file images associated with that user and session, that we need to store. So we understood now the two things about the contextual engineering. So we are talking about, if we miss, let's what we are talking about. So context engineering covers the assembly of complex payload, okay, and this context engineering include these components, okay. So now we understood the context engineering, right? Now we are talking about what are the things we are including in the context engineering. The first part, that what we understood from context engineering, these are the guides, okay. So we have to include the system instruction, tool definition, few short example, right? These are the things that we need to do. This is the basic of your context engineering. Once you've done with that, then these are the Three, then we have to provide with the data. So I can say that this information is about the what to do. Okay, so these are something called as an instruction to your LM. For me, this information about the D, that is the data which will support your action. Okay, so what actions LLM is going to do? For this, we need to provide the system instruction, tool definition, and few shot. To do this action, we also provide some support information. So for that, we are providing this long-term memory, external knowledge, sub-agent output, everything. So first will be the action, second will be the data, and the third part, let's check. The third part is about the immediate conversational information. So what it says, grounds the agent in the current interaction and define immediate task, that what next action we need to do. So this conversational history, the turn by turn record of the current interaction. So we need to store you the conversational history. State and scratch pad, temporary or in progress information or calculation the agent uses for its immediate reasoning process. And third is the immediate query to be addressed. Okay, so what immediate action that agent has to do, right? This information that we have to provide in the context part, right? So these are the third point while we are building the context engineering, right? I think very simple that what we wanted to do or what we wanted to build during the context engineering. Let's move to the next part. The dynamic construction of context is critical, definitely. Memories, for instance, are not static. Totally agree. They must selectively retrieve and update it as the user interacts with the agent or new data is ingested. Additionally, effective reasoning often rely on in-context learning. What is in-context learning? So they have given definition in bracket. A process where LLM learn how to perform tasks from demonstration in the prompt. Right? So for example, in context learning, you are asking LLM to do this action, right? For example, let's take an example that we are asking to make a rice and we have added this task, right? These are the actions, right? So with the example, the instruction that we are giving prompt, LLM try to learn from that. Okay. So whatever informations we are providing within that context, okay, the LLM try to learn and demonstrate. So this is called as a in-context learning. So in-context learning can be more effective when agent uses the few shot example, and that's the reason we are giving few shot example, right? Otherwise, we are giving instruction, we are giving tool, but if we are not giving example how to do that, then it might be possibility that LLM can do anything else, right? For example, we are giving asking LLM to make a rice from this, and for that we are giving the you know ingredients and tools, so it may be possibility that it can come up with something different else. So that's the reason we are giving the example rather than relying hard-coded ones. Similarly, external knowledge retriever RAG tools based on user immediate queries. So I think this is pretty clear that we understood. Let's go to the next para. So one of the most critical challenge in building context aware agent is managing an ever going conversation history, and I think this is a major problem, right? And this is a realistic problem, again, frankly speaking. This is not just because it possibility that you are how long you can giving the conversation history. You keep asking question, you keep doing, but the growing conversation history is the major stuff. So in theory, model with the large context zone can handle extensive transcript, definitely, but in practice, as the context grow, then these two major factor also impact cost and the latency increase, right? Because the more questions you ask, the more token you are going to utilize. The more token you are going to utilize, the more cost will increase, the embedding model and all these things. And again, the shorter the form, quick the response, longer the form, latency will be high. And then model can suffer from context rot. So this is a new word I am also reading. So what is context rot? It is a phenomenon where their ability to pay attention to critical information diminishes as the context grows. So this is a great thing, right? I think everyone knows, but this is the word that they are using for this. And I think everyone agrees, right? The more and more informations you are giving, there is a high possibility that LLM loses their attention to the critical informations. So when LLM critical loses their information about the critical information, then this is called as a context rot. So please note down, if you are keeping, you are having the pen and notebook with you, so please write this word. This will be helpful. So context engineering directly addresses this by employing the strategy to dynamically mutate the history, such as a summarization, selective pruning, other compaction technique, to preserve the vital information while managing the overall token count, ultimately leading to more robust and personalized AI experience. So this is the way to deal with the context rot. So how we can deal with the context rot? So definitely, maybe most of you are aware, but yeah, we are usually giving the whole information. We are trying to give the summarized way. Second way, rather than giving whole information, we are giving only selected information. This is called as a selective pruning. Pruning means cutting the cutting the unimportant information, only giving the important stuff. Okay, and maybe there are maybe other compressing technique or compaction technique to use, right? So this way, what will happen, rather than giving whole conversation, we are just giving the important information so that we are saving the overall token, and this will be leading to the much more robust and personalized information. So this is great. So now the new word we learned, top or we learn about the context rot and how we can overcome the context rot with this technique. Great. Let's move to the next. So this is the practice manifest as continuous cycle with agent operational loop for each turn of conversation. So let's say when we are asking user questions, directly asking question, we fetch the context, right? Now how this context will fetch? So this context will fetch from the context storage. Okay, so let's say this is the agent and this is the box where this is an agent, then this is a response and the streaming. So we are fetching this, and this will be the async mode. Okay, then we prepare the context, and when we are saying prepare the context, so we are uploading the context. So whatever events we are doing, we are uploading here, and then we are invoking the LLM plus tool based on the informations. So this is the flow of context management for the agent, and I think everyone is know. So whenever we are asking user, again I'm repeating, sorry, this is the loop. Every time we are user is asking question, we are fetching the relevant information from our storage through RAG or some other techniques. Then we are preparing the context, right? Upload the useful events through the conversation that we had, and then we are invoking, and then this will keep going. This is a pretty explainable diagram. Let's move to the first. Okay, so let's understand first is the okay, so this is about the explanation about each topic. So when I say fetch content, okay, now when we are talking about the fetch content, the agent begin by retrieving the context. Okay, so when we are saying fetch the context, so what we are fetching? We are fetching user memories, RAG, document, and recent conversation event. So for dynamic context retrieval, the agent will use the user query and the other metadata to identify what informations to retrieve, right? So this is about the fetching. So how we are fetching the informations? So based on the user query and other metadata, we are retrieving the informations, okay, from the RAG, from the database, from the conversation events, likewise. Next is the prepare the context. So we are talking about this now, this block. Fetch context is understand how we are fetching, right? Now we are talking about the prepare the context. So when we are going to the prepare context, the agent framework, right, dynamically construct. Again, see, here we are not doing anything statically. Everything happened dynamically. Please remember this word. Okay, everything happened dynamically. The full prompt for the LLM call, although individual API call may be asynchronous, preparing the context is a blocking. So this is called as a hot path process. Okay, so agent cannot proceed until the context is ready. Okay, so this is very important, right? So once we fetch the context, the second step will be called as a prepare the context. So what will happen in the prepare context? We are preparing the full prompt, okay, for the LLM call. And here, though it's asynchronous, but please remember, preparing the context is a blocking. Unless until we are not preparing the context, we are not sending the questions to the LLM, right? This is very important. Okay, if you are, and this is called as a hot path process, so they are giving the name is a hot path. Okay, unless until the context is not ready. Next is the invoke LLM and tools. So what will happen in invoke LLMs and tools? The agent iteratively call the LLM and any necessary tools until final LLM response for the user is generated. Tool and model output is appended to the context, right? So generally we are aware, right? So whenever you calling the LLM, one thing is note that you are passing the LLM prompt, and then LLM take the LLM understand, give the tool will generate the output, and again this output is appended. So this is the third information is very important, right? So what will happen? The tool and the model output is appended to the context. Okay, it is not that you are giving the response, that's it. No, this again is getting appended into the context. So these three steps is very important to remember. And then once you done, once you appended, once you receive your output, it is very important that output has to again store into the upload context. Otherwise we are losing the context, and again this process is going on. Now if you look at this, this is the what they are saying. So whatever new information is generated here, gathered during this turn, is uploaded again to the what? Persistent storage. And this is often a background process allowing agent to complete the execution while memory consolidation or other post processing occurs asynchronously, right? So these are the four stage. It's very much important to remember while working with the context engineering. So let's repeat once again. The first is a fetch the context. Second is the First is the fetch the context. Second is the prepare the context. Third is the invoke the LLM, right? And the fourth is upload the context. Now, at the heart of this life cycle, there are two fundamental components, very important, that we are going to talk. That is something session and memory. So what session? Session manages the turn by turn state of single conversation. So whatever we are doing conversation will manage that, and memory in contrast provide mechanism for long-term persistent and capturing and consolidating key information across the multiple session. So I can say, as I already explained, memory is responsible for provide the useful information across the session, and session is for the particular conversation. Now you can think, they are saying, you can you can think of session as the workbench. Okay, you can think session as a workbench or desk you are using for specific project, right? While you are working, it is covered in in all necessary tools, notes, reference material, everything is immediately accessible, but also temporary, right? This all information is what? Temporary. So whatever information is available, it's a in the session, it's a temporary and specific to the task. So for example, if you are doing, let's say, working on coding stuff, so maybe a VS Code or PyCharm or the GitHub tool access, these are the accessible to you. But if you are working on something called as a documentation, so maybe during that time different tools are important, right? So once the project is finished, you don't show the entire messages into storage. Instead, you begin process of creating a memory while like a organized filing cabinet. So you can review the material on the desk, discard the rough draft. So whatever the rough was you are creating, that you are discard that, and then redundant notes also, and file away only the most critical and finalized document into label folder. This ensures that filing a cabinet remains clean, reliable, and efficient source of truth for all future projects without being clutter and transient chaos of the workbench. So this analogy directly mirrors how effective agent operates. The session serves the temporary workbench for single conversation. I think please note this is a very nice analogy they are giving. So session, what is session? Session serve as the temporary workbench for single conversation. For example, you are working on one of the project, right? So that is a temporary. While agent memory is a meticulously organized filing cabinet and allowing it to recall key information during future interactions, right? So as simple as that they are giving. I think don't think so. This require any explanation, right? On top of that, now building this high level overview of context engineering, we can now explore two core components, that is the session and memory. And now we are going to begin with the session. But I think I'll take the session topic in next video. But I hope everyone understood what is context engineering. I hope you like the way I'm going through this paper. Still there are a lot ways to go. We will divide the upcoming video also in multiple the multiple lectures. Okay, but yeah, if you like the way, please like and subscribe, and feel free to do the comment in the comment section of this video. Till that time, have a nice day and all the best. Thank you.